Hi, this is Sean DiPietro, Miss Bowles 3 CP Physics class, and I'm about to take you through the physics of the catapult. The term catapult was derived from the Greek word katapultos. A catapult was a large machine on wheels with a basket attached to a long wooden arm and a power source for hurling projectiles onto the enemy. The first catapult, however, was invented around 400 BC in a Greek town called Syracuse. The first catapult closely resembled a crossbow. There are different kinds of catapults, some being the generic catapult, the gastrophyte, the ballista, and finally the trebuchet. All four types accomplish the same goal, but with different kind of tactics. The generic catapult used tension instead of traction, torsion, and gravity. These types of tension-powered catapults had a long, flexible arm so that when the basket was bent backwards to give the weapon its throwing power, the arm would not break, making the weapon useless in battle. The basket was tied or hooked in some way when bent backwards, so that large stones or other types of projectiles could be loaded into the basket. When the basket was released, the projectile would fly into the air, hopefully hitting the castle wall and causing part of it to tumble to the ground. Sometimes flaming projectiles were put into the basket. Upon impact, the ball would burst, setting fire to everything in a given radius. The tension-powered catapult was often used for destruction of castle walls, but sometimes it was used as a defense weapon from the castle itself. The tension catapult was able to throw and shoot faster than most other types. It was also a better weapon than the ballista, as the catapult was portable with its wheels. Physics is involved in catapults in many ways. The entire catapulting process depends on the storing of potential energy as tension or gravitational potential energy. There are 5 steps to show the physics behind the catapult. First, you pull back the arm. Second, you place the missile in the bucket. Third, you release potential energy, which is in the arm. Therefore, the work is done for the arm. Fourth, the arm collides with the base and is brought to an abrupt stop. And finally, the missile, or whatever you're throwing, will retain the kinetic energy from the work done on the arm. The kinetic energy launches the missiles at the target. The physics equation that we would use for a catapult would be potential energy equals mass times gravity times height. We also learned of another equation called the range equation, but we only could use this if the catapult is at the same level as where the missile is about to hit. This here is a video of me and Jared using one of the catapults that the CAD 2 class made in our high school. Now here in this upcoming video is the world's largest catapult ever made, and it's kind of used for fun in this case.
Now, to fancy a fling on your winter holiday, taking off from Teen, this enterprising Frenchman is catapulting the world of extreme sports to new heights. Yes, literally. So if you'd like a little alpine adventure, buckle up, brace yourself, and just remember to pull the parachute cord.
As you can see from the prior video, catapults aren't really used in medieval times anymore since we're not in them. They're used more for fun projects or fun things to make or just something fun to do. There's no real practical use for them since the trebuchet and others are deemed better, but they are always fun to look at, and you can see some old ones in Europe that are still could be used today. This concludes my CP Physics project on catapults. I hope you enjoyed it. Thank you for watching it.
Rim chop on the beat. I can't spell so.